Today, the plastic industry is facing a huge challenge. For us to reach net zero by 2050, we need to cut carbon emissions across our whole supply chain, from our raw material sources and manufacturing process right through to our product's end of life. The most important step to achieve this is we need to build a circular economy for plastics. We need urgently to start making plastics from raw materials rather than oil and gas extracted from the ground. These alternative raw materials can be made from bio-waste sources and, even better, come from plastic waste itself, which allows us to return more plastic back to being useful once again. We also need to use more recycled plastic content in every application. And this will help us reach the EU's legal recycling and recycled content targets. Therefore, where are our biggest opportunities? Sadly, plastic recycling rates are far too low and too much plastic is being lost to waste, being currently incinerated or ending up in landfill. Today in Europe, up to 2/3 of plastic is not recycled. To solve this problem, first, we as a society need to improve the separation and the sorting of plastic waste, as well as our collection and recycling infrastructure. This means more targeted sorting of mixed solid waste so we can divert all recyclable materials, including plastics, from ending up in landfill or being incinerated. All waste can be a resource. We support mandatory recycled plastics targets for every application and in every product we buy, which will in turn help to create a clear market demand. With a clear market for broader use of plastic waste, the whole value chain, from waste managers to producers to recyclers, will then invest in the expansion of the recycling infrastructure across Europe that we all need. Ultimately, our aim is to create a fully circular plastic system across the EU where every type of plastic waste is recycled. We want to meet the quality needs of every application using plastic with minimal environmental impact. To achieve this, we need to expand today's collection, sorting, and recovery of plastic waste. An awful lot of plastic waste is incinerated or landfilled, which is unacceptable. We will need to work all together to bring this plastic waste back to the recycling industry. By adding an extra complementary chemical recycling loop, we will be able to recycle a broader range of plastics that right now aren't recycled at the scale or quality we need in our daily life. Now, what is chemical recycling? Essentially, it's a process that turns plastic waste, which is hard to recycle, into an oil or gas. This oil, in turn, is used to make high-quality, high-value recycled plastics. The type of waste that can be recycled varies, depending on the technology that's used, but includes a range of plastic materials that are not suitable for mechanical recycling processes. Chemical recycling turns plastic waste into a variety of outputs, from specific polymer blocks to syngas to pyrolysis oil. These materials can then be used as alternative raw materials to fossil-based oil in our existing production processes with the purpose to produce plastic with recycled content. Now, why do we need chemical recycling? Chemical recycling enables the production of plastic with the virgin-like quality needed for highly regulated applications like food, cosmetic, personal care packaging, and the automotive industry. Therefore, in chemical recycling, plastic waste is used to produce new high-performance plastics again. Some advanced mechanical recycling systems, which work in controlled closed-loop conditions and primarily handle clearly identifiable types of plastic waste, like milk bottles, can provide again food contact qualities. Unfortunately, When plastic is recycled many times mechanically, polymers will degrade and not always and for long be able to be used in the circular economy. However, the technical and economic limitations of this technology mean that it cannot be scaled across all contact-sensitive plastic and packaging applications that we have. The reason for this is that plastic waste is often in contact with various other types of waste, and cleaning it up for bringing it back into the mentioned applications requires chemical processes, not only mechanical ones. Again, to emphasize, only by scaling up both mechanical and chemical recycling will we be able to meet the needs of tomorrow's circular economy and our net zero ambition. To enable and scale up investment in chemical recycling, we need both chemical recycling and mass balance accounting to be formally and legally recognized. So let's do a deep dive into mass balance. Let's start with what you may recognize: the mass balance models which already exist. Most of us are aware, or maybe you are not, that the electricity we purchase is a combination of solar and wind generated electricity and traditional oil or coal-based electricity. And it will be a combination of both as we transition from fossil-based energy to green renewable energy. When you purchase renewable electricity and receive a certificate, this demand for renewable electricity incentivizes the power industry to invest in more renewable electricity generation. The solar and wind-powered electricity that goes into the grid will grow, and the coal and oil-based electricity will diminish. So even if your local electricity is coal-based, as a consumer, you can support the increase of renewable electricity generation by incentivizing the energy companies to increase the share of renewable electricity. It's the same for aviation fuels. Sustainable aviation fuels are certified using mass balance models. They enable fewer emissions by substituting fossil fuel with sustainable ones. So when you buy a flight ticket with sustainable aviation fuel certificates, you are contributing to the growth of sustainable aviation fuel and helping to grow this industry. Although the plane you're flying on is still using traditional fuels as well. This is a transition, a switch. So what's the relevance of mass balance to chemical recycling? The models mentioned are designed to assess sustainability characteristics, and for plastics made with chemical recycling, it's the same. It's a model that's been formally recognized in the EU renewable energy market for some time. A mass balance enables us to mix virgin fossil raw materials with circular and renewable raw materials. When we take plastic-based oil made with chemically recycled oil and we mix it in our large existing plant production systems, the quantity is small compared to the scale of the industry. As the plastic waste-based oil is turned into building blocks of new plastic, it cannot be tracked individually. We, however, know how much fossil-based oil we replace with plastic waste-based oil. And this we can transfer to the new plastic we produce using this alternative raw material. So mass balance accounting allows us to calculate how much waste-based plastic we produce, and this process is audited and traceable by external auditing companies. Therefore, the customers and consumers that want to buy food packaging with recycled content know that the fossil-based oil has been replaced by waste-based plastic oil. And if we want to meet ambitious recycled content targets in every product, we need to adopt this approach, which is called mass balance accounting with credit method. This means that all circular raw materials are fully traceable and can be audited and verified by independent third party. Manufacturers can then sell these circular plastics to markets demanding greater circularity. And brand owners can tell consumers about the amount of recycled content in their products in a credible and understandable way. Let's look at the benefits of this approach. Crucially, most mass balance models avoid the need to duplicate our existing production and logistics systems. This means we do not need to build and run separate infrastructure that focuses solely on the circular raw materials, which would involve huge investment costs and increase our carbon emissions. For these reasons, a mass balance model is not only the fastest way to accelerate the use of recycled and renewable raw materials for plastics, but the most cost-efficient and most carbon-efficient one, with the lowest environmental impact. The recycled content can then be freely allocated to all materials and to the markets with the greatest demand for circularity. It would also maximize the use of recycled content in a way that's fast, traceable, and cost-effective with minimum impact on the environment. It helps us, the plastics industry, to make the switch into a sustainable production system. To conclude with another example, mass balance is also used in fair trade certification, to trace certified sustainable crops that are mixed with non-fair trade products during complex manufacturing and logistic processes. We all like buying fair trade products, right? Because we know it's a system that is heading in the right direction. So in short, a mass balance approach means that materials with specific sustainability characteristics are mixed or balanced with others. Let's talk about our proposed steps to achieve circularity. This is why we believe a complementary chemical recycling loop underpinned by mass balance model is vital to meet the EU's proposed recycling and recycled content targets and meet growing market demands for high-quality recycled plastics. However, aside from the practical challenges of scaling up this technology, we also face some policy barriers. Today, neither chemical recycling nor mass balance models are legally recognized. This means that despite the significant benefits, this approach won't count towards the legal obligation for recycled content for brand owners, retailers, or automotive manufacturers. Nor will it count towards member states' legal targets for recycling plastic packaging. It would also make circular products less affordable for consumers and inadvertently have a greater environmental impact. For example, by increasing the industry's carbon footprint. So the policy framework for this is a must. That's why Dow and others within the industry are calling on the EU's Commission to legally recognize chemical recycling and mass balance accounting models. It would also make circular products less affordable for consumers and inadvertently have a greater environmental impact. For example, by increasing the industry's carbon footprint. So the policy framework for this is a must. As you've probably gathered, Dow is passionate about innovating and investing to scale up both mechanical and chemical recycling. That's why we are investing in a whole range of ambitious projects and partnerships with innovative and entrepreneurial startups and companies to expand and advance these technologies, using our innovation and expertise to find new paths to a sustainable future. And we are calling on industry, policymakers, and society as a whole to join us in this journey by helping us scale up and support the right technologies to reach our goals. Only by working together today can we build a circular and net zero future. Are you with us?